Hello, grade 12s. This is our last lesson of the acids-basic unit on buffers. So what I want you to get from this lesson is, what are buffers and what do they do? Well, what buffers are solutions that resist changes in pH. So we're not going to have this solution, if we add an acid, all of a sudden have the pH drop really low, and if we add a base, it's not going to go up really high. Now, they do this by absorbing the protons that we get from adding a hydrogen, or the hydroxide we get from adding a base. They kind of soak it up, so to speak. We make a buffer by mixing a weak acid or base with its corresponding salt. So I'm going to use the example of ethanoic acid, which is a weak acid, which means very little of it separates into ions in water. And the salts we're going to use is sodium ethanoate. We know that ethanoate ion is present in both. It's a common ion. And sodium ethanoate is a salt, so that would be very soluble in water. So when I add an acid to this, the ethanoate ion will be able to absorb any of the protons, so the pH won't drop. And if I add a base, the acetic acid will react with the base and prevent the pH from going up. And let me show you how this works. So here's my acetic acid, which we know to be a weak acid. So very little of it will break apart to form acetate ion and protons, hydrogen ion. So we're going to have lots of the acetic acid in my water. To the water, I'm also going to add my sodium ethanoate. Now, being a salt, it's going to dissociate completely. So we'll use one-way arrows, and it'll dissociate completely to form the ethanoate ion and the sodium ion. So the species I have highlighted in yellow here will be present in large amounts. Now look what happens when I add an acid. If I add an acid, which gives me a source of protons, which could of course drop my pH, those protons are strongly attracted to one of these three species I have in large amount. And the one that's an obvious attraction is the ethanoate with a negative charge. So when my protons react with the ethanoate ion that I have lots of, they reform acetic acid. And because acetic acid doesn't break apart very well to release protons, my pH will not go down. What happens though if I were to add a base? Well, bases add hydroxide. Hydroxide has a -1 charge. So which of these three species do I have in large amounts that would really attract the hydroxide? Well, sodium's a likely possibility, but sodium hydroxide is also super soluble in water, so that would just stay separated out, and I'd still have lots of hydroxides. The other possibility is the acetic acid. The hydroxide will remove protons from the acetic acid. Being a strong base, it'll rip them right off to form water molecules and acetate ions. Neither of these two species will change the pH. So by having my weak acid and its corresponding salt in water, I have acetate ions, in this case, that are capable of removing extra protons from the solution, and acetic acid, which is capable of removing excess base. And so this is the way that buffer solutions prevent your pH from going up and down dramatically. Those of you who have a hot tub or a pool will be adding lots of different kinds of salts, including baking soda, which is a weak base. They quite often call it alkalinity increaser in your pool supply stores. It's just baking soda is all that it is. And that is part of its buffering solution so that your pH doesn't fluctuate wildly in your hot tub. So obviously there's going to be a limit. Once we've used up all of my weak acid or base and the corresponding salt ion, then any excess acid or base that is added will have a very fast change on the pH. And so that limit is called the buffer capacity. And that's why, for example, if we're considering the idea of hot tub chemistry, we will always constantly be having to add new buffer solutions because there's always going to be a limit. Now, I've got a very short assignment for you with this one. I want you to do a short little reading in your textbook out of chapter 18 about buffers. And there's two things I want you to find out. I want you to note, how are buffers useful in the human body? Okay, and give me an example for that. So that's the simple example that I want you guys to take a look at. There's lots of crazy little memes out there and places on the internet that talk about how people should eat alkaline diets or they should eat acid diets, and they've got all these wonderful ideas about that. And with body chemistry being what it is, any rapid changes in pH would probably kill you because our body chemistry is highly dependent on acidity levels, on our pH levels in our body. So eating lemons, for example, if we didn't have buffering systems, would tank our pH very quickly, and eating something that was basic, something bitter tasting like cabbage, would bring our pH way up. And so we want to take a look at what could we do and how are these buffers used in the body. So it's a short little read and a good link between chemistry and biology. And that is the last of our lessons for our acids and bases unit.